So today we will start soil mechanics, soil mechanics, chapter number 3, soil mechanics, chapter number 3. And the name of this chapter is clay mineral and soil structure. Clay mineral and soil structure. Okay. So in this lecture, we will cover uh, engineering service exam previous year questions. Okay. From till 2024. Okay. So let us start with question number 1. So I'm erasing. Let us start with question number 1. So question number 1 is a black cotton soil are clays and they exhibit characteristic property of swelling. Yes, this statement is correct. This statement is correct. These clays contain montmorillonite. These clays contain montmorillonite, which attract external water into its lattice structure. Yes, this statement is also correct. And because of montmorillonite, the uh, black cotton soil uh, has swelling properties. Okay, so a statement assertion is correct. Assertion is correct. Assertion is correct, and R is the explanation of A. Okay, so let me explain this question in detail. So montmorillonite belong to the 2:1 clay mineral group. Okay, let me explain uh, all all points related to this question. So the first point is montmorillonite montmorillonite belong to belong to 2:1 2:1, that is 2 is silica, 2 silica is to 1 alumina. The 2:1 clay mineral group. Clay mineral group, that is 2 silica, that is 2 silica, 2 silica, tetrahedral sheet, tetrahedral tetrahedral sheet, sandwiching one aluminium octahedral sheet, one aluminium octahedral sheet. Okay, the structure is like that. This is silica sheet, tetrahedral silica sheet, and this is alumina sheet, gypsite. Okay, and this is again Acetic acid, acetic acid, and this thickness is 9.6 angstrom. And another unit is test with van der Waals force. This is very weak force. So this is Si, Si, and this is aluminum, acid. And this structure, this unit is connected by, attached by van der Waals force. Attached by van der Waals force. And well, van der Waals force. And this is very weak. It is weak bond. Weak bond. This is very weak bond. Okay. So the bond between these layers. Next point. The bond between these layers is a weak van der Waals. Is a weak and weak van der Waals bond. Weak van der Waals bond. Because this bond is so weak, because this bond, because this bond is so weak, is so weak, is so weak, water molecule can, water molecule can easily enter, easily enters, easily enters between the layer, between the layers, the lattice structure. Okay, as water enters, as water as water enters, it pushes the layer, it pushes the layers apart, causing the physical volume, causing the physical volume of soil increases, of soil increases. Okay, and black cotton soil contains, black cotton soil contains, black cotton soil contains montmorillonite, montmorillonite, which attract, which attract external water, external water into its lattice structure, into its lattice structure. Okay, so statement A is correct, assertion is correct, reason is correct, and the reason is correct explanation of assertion. So answer is A. Okay, so now I'm taking question number 2. Question number 2. The correct sequence of plasticity of material in soil in increasing order is. So plasticity is highest in case of montmorillonite, and intermediate in case of elite, and least in case of kyanolite as compared to elite and moldmonite. But silica has the least uh, plasticity, then kyanolite, then elite, then moldmonite. So answer will be A. So plasticity in clay mineral, plasticity, plasticity in clay mineral, clay mineral is directly related to the specific specific surface area, specific surface area, that is surface area per unit mass, that is surface area per unit mass, and the strength of the bonds, and the strength and the strength of the bond, the strength of the bonds between the molecular layer, between the molecular molecular layers. Okay, this is the plasticity. So first is silica. First one is silica. So silica is sand slash silt size. For this is a non-plastic material. Silica is this is a non-plastic. This is a non-plastic material. It has no cohesive property. It has no cohesive. It has no cohesive property. No cohesive properties. It has no cohesive properties or ability to hold water, or ability to hold water in a plastic state. Plastic state. Now, second one is kaolinite. 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 So it has a 1:1 lattice structure. It has 1:1 lattice structure. Lattice structure. 1:1 lattice structure held together. Held. Give me 1 second. Held together. Held. Held together. Held together by a strong hydrogen bond. By strong hydrogen. By strong hydrogen bonds. These bonds are so strong. These bonds are so strong that water cannot easily that water cannot easily water cannot easily enter between the layers, enters between the layers, resulting in low swelling, resulting in low swelling and the lowest plasticity among clay, and the lowest plasticity among clay and the structure looks like this. Structure look like this. That is gypsite sheet, aluminium, aluminium, and this is silica sheet. Unit One unit of kyanite is this. This is silica sheet, Si, and this is attached by van der Waals force with another unit, Si, Si, and uh, this is hydrogen bonding. This is hydrogen bond held by hydrogen bond, held by a hydrogen bond, strong, very strong. Okay, so this is about kyanite. It is commonly found in sedimentary and residual soil. It is commonly found. It is commonly found in it is commonly found in sedimentary and residual rock. Sedimentary and residual rocks. Okay. Sorry, residual soils. Residual soils. Okay. So this is all about kyanite. Now let's see elite. 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 So it has 2:1. It has 2:2. It has 2:1 lattice structure. Lattice structure. 2:1 lattice structure held together by held together by held together by ionic bonds. Ionic bonds. That is potassium ion. Potassium ion. K plus. These are stronger than these bonds are stronger than van der Waal force, van der Waal bonds, but but weaker than hydrogen bonds. Okay, placing its plasticity It's placing its plasticity in middle. In placing its plasticity in middle. Okay. So now the structure of elite is same like montmorillonite. This is tetrahedron unit, silica, silica. This is octahedron unit. This is again tetrahedral unit. This is tetrahedral unit. This is octahedral. This is tetrahedral unit silica. And in between these K plus K plus bond is there. This anic bond. Anic. Anic bond. Okay. So let me explain about montmorillonite. Very important. Let me clean this one. Montmorillonite. 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 Okay. So it is also a 2:1 lattice structure, same as elite, similar to elite. Okay. 2:1 lattice structure, but held by very weak, very weak van der Waal, van der Waal bond, van der Waal bonds. This allows for this allows for the highest water absorption, the highest water, highest water absorption, and the highest plasticity, and the highest and the highest plasticity. Okay, let me make a chart, and this is very important chart. Always remember this chart. Mineral mineral structure, mineral structure, bond type, and plasticity. If mineral is silica, if mineral is if mineral is silica, if mineral is silica, if mineral is silica, the structure will be crystalline. The structure will be the structure will be crystalline, and the bond type is covalent bond. Covalent bond. The plasticity none. There is no plasticity in case of silica. Okay. If mineral is kieranite, then the structure will be, this is 1:1 structure, 1:1 structure, and the bond is hydrogen. hydrogen bond strong, plasticity low. If the mineral is elite, then this is 2 is to 1 mineral, and the bond is ionic potassium. This is medium, and plasticity is also medium. And in case of montmorillonite, the mineral is 2 is to 1, and the bond type is van der Waals, van der Waals bond, van der Waals bond, that is weak. This is strong, this is medium, this is weak. Okay, and the plasticity is highest. Plasticity is highest. Okay, so this is all about this question, and this chart is very important. This chart is very important. Just looking at this chart, you can answer question number 2. Okay, the answer will be what? A. The answer will be A. The answer will be A. This is all about question number 2. Now we will see question number 3. The predominant mineral responsible for shrinkage and swelling in black cotton soil is, that is montmorillonite. The answer will be D. The question number 3 answer will be D. Now question number 4. Question number 4. Consider the following statement. A dispersed structure is formed in a clay when the net when the net electrical force between adjacent soil particle at the time of deposition are repulsive. Yes, this statement is correct. Let's see the second statement. A dispersed structure is formed in clay when remolding and compacting of clay having high void ratio. Demolding and compacting of clays. A dispersed structure is formed in clay when remolding and compacting of clays having high void ratio. Yes, this statement is also correct. This statement is also correct. Statement 3. There is a concentration of dissolved mineral in water. So a dispersed structure is formed in clay when there is a concentration of a dissolved mineral in water. No, in this case, the flocculent structure will form. So this statement is wrong. Next statement is platelets have face-to-face contact in more or less parallel arrays. Yes, this statement is also correct. So 1, 2, and 4 is correct. So option C will be the answer. Okay, let me explain this question in detail. So a dispersed structure, a dispersed structure, a dispersed structure, a dispersed structure in a clay is in a clay is characterized 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 by particle particle arranged in particle particle arranged particle arranged in a parallel orientation in a parallel orientation, in a parallel orientation due to dominant repulsive forces, due to dominant repulsive repulsive forces. So what is statement 1? Statement 1, see statement 1. A dispersed structure forms a dispersed structure forms forms when the net electrical forces when the net electrical forces between adjacent soil between between adjacent between adjacent soil particles particles at the time of deposition at the time of deposition at the time of deposition are repulsive are repulsive. This repulsion prevents this repulsion this repulsion prevents the particle from particle from sticking together st- sticking together in random orientation. Now statement 2, but it says remolding and compacting of clays having high void ratio. So the dispersed structure are often the result of dispersed dispersed structures are often the result of often the results of remolding remolding and and compacting clays, especially those with especially especially those with those especially those with high wide ratios, as the mechanical action as the mechanical action forces the particle forces the particle forces the particles into parallel parallel alignment. Now what is statement 3? Statement 3, there is concentration of dissolved minerals in water. So this statement is wrong. The statement 3 is wrong statement. Why? Because high concentration high high concentration of dissolved minerals, that is electrolytes in water water usually reduces the repulsive reduces usually reduces the repulsive double layer leading to an attractive that is flocculent structure rather than a dispersed one. Okay. Now statement 4. Statement 4. By definition, a dispersed structure by definition a dispersed structure is is one where where clay particles have face to face to face contact contact and are and are arranged in more or less arranged in more or less parallel arrays more or less parallel arrays. Okay, so according to these explanation, option 3, uh, statement 1, 2 and 4 is correct, so option C will be the answer. Okay, so a very important table I am going to give you, a very important table. Let me write here this table that is very important related to this question. Okay, very important table and related to this question. So in this table, that is one column is for features, and the next column is dispersed structure, dispersed structure, dispersed structure, dispersed structure, and flocculent structure, flocculated structure, flocculated structure. So feature is particle orientation, particle particle orientation. In dispersed structure, it is parallel, face to parallel, that is face to face. Particle orientation in dispersed structure is parallel, that is face to face. Okay, and in flocculent structure, it is edge to face or edge to edge. S to phase or S to S. S to S to S. So particle orientation. First is particle orientation. Second, dominant force. Dominant force. In this, it is repulsive. And in flocculent structure, it will be attractive. Dominant force. The next is formation method. Formation method. In dispersed structure, it will be formed by compaction or remolding. Compaction or remolding. Compaction or remolding. And in this case, deposition in salt water. Okay, deposition in salt water. Deposition in salt water. Deposition in salty water. So in that is marine deposits, the soil of marine deposits is it has flocculated structure, and in the deposits, the soil deposit in lakes is of dispersed structure, and this is dispersed structure. Okay, so the next is permeability. In case of dispersed structure, it is low, and in case of flocculent structure, it is high. Okay, this table is very important. This table is very important. So remember this table. Very easy table. You can remember this easily. Okay, so then this is all about question number 4. Answer will be C. Okay. Now question number 5. Question number 5. Consider the following clay minerals. First is kaolinite, second is illite, and third is montmorillonite. Which one of the following is the correct sequence of mineral given above in the increasing order of their size? So for this question, um, the size of montmorillonite is least, and illite is in intermediate state, and kaolinite has the largest size um, in these options. So the answer will be increasing order. So 3 to 1. 3 to 1. A will be the answer. 5. A will be the answer. So for this question, I am going to make a table, and that is very important table. In this, that is clay mineral. One column is for clay mineral. The other is grain size, grain size, grain size, and base exchange capacity, base exchange, base exchange capacity, and third column is for plasticity index, and fifth is for dry strength, dry strength. The last is for activity. So if clay mineral is montmorillonite, montmorillonite, illite and kaolinite, illite and kaolinite. So grain size is in this case minimum, elite is in between, so intermediate, and curlite size is maximum. Base exchange capacity of monomolinite is high, that is largest. Elite is in between, so intermediate, and in case of kernite least. IP in case of monomolinite is maximum. This is in between, intermediate, and this is minimum in case of kernite. Dry strength in case of monomolinite is maximum. For elite, it is intermediate, and the kernite case of kernite is minimum. Activity is largest in case of monomolinite. This is intermediate, and this is least. Very important table, very easy to remember. Okay, elite is in intermediate always. Okay, so according to this table, column 2, the size of monomonite is least, then elite, and the largest size of mineral, that is kieranite. So A will be the answer. Question number 5. Now question number 6. Question number 6. Consider the following statement. Mica is a clay mineral. No, this is not a clay mineral. This is rock forming mineral. So this statement is incorrect. This is mica is rock forming mineral, not clay mineral. Not clay mineral. This statement is wrong. Rock dust particles, even of clay size, are non-plastic. Yes, rock dust. This statement is correct because plasticity depends on its chemical composition of minerals. So rock dust, even if its size become less than clay, it will remain non-plastic. Okay, so this statement is correct. Statement third: a particle of kernite is electrically charged. Yes, this is also correct. So 2 and 3 statement is correct. One is wrong. The option will be C. So question number 6, answer will be C. So let me explain this in detail. Statement 1. Statement 1, what it says: mica is clay mineral. No, this is not. Mica is a rock forming mineral. Mica is a rock forming mineral. Mica is rock forming mineral, not a clay mineral. Not a clay. Clay mineral is elite, montmorillonite, kieranite. Okay, these are clay minerals, but mica is not a clay mineral. This is rock mineral. So this statement is incorrect. Now statement 2. So statement 2 is rock dust particle, even of clay size, are non-plastic. So this is correct statement. Plasticity is a property. Plasticity is a property derived from derived from the electrochemical forces. The electrochemical chemical, electrochemical forces between these clay minerals, between these clay, between these clay minerals. Rock dust, rock dust, even when, even, even when grounded to, grounded to a very fine clay size, grounded to a very fine clay size, clay size, very fine clay size, less than 0.002 mm, does not possesses, does not, does not possesses the mineralogical properties, the mineralogical properties or surface charge required, or surface charge required to exhibit plasticity, to exhibit, required, required to exhibit, required to exhibit plasticity, plasticity. Okay. Now statement 3. What is statement 3? A particle of kyanite is electrically charged. Yes. Like all clay minerals, like all clay, like all clay minerals, minerals, a particle of kyanite, particle of kyanite, particle of, particle of kyanite is electrically, electrically charged, electrically charged. It typically carries a, it it typically carries a negative charge, a negative charge on its surface, on its surface, on its surface, and the positive charge, and the positive charge, and the positive charge on its edge, on its edge, which plays a major role, which plays a major role, which plays a major role in how it interacts, major role in how, in how it interacts how it interacts with water and other particle with water and other particle other other particles. Okay, so there's a note for this question. There's a note for this question. This question highlights the difference between this this question highlights 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 the difference between the difference highlights the difference between size and mineralogy. Size and mineralogy. Size and mineralogy. Just because a particle is small, just because just because a particle is small, just because a particle is small, just because a particle is small enough to classify it as clay size, particle is small enough to be classified as to be classified as classified as clay sized clay clay sized doesn't mean like rock dust, like rock dust, like rock dust doesn't mean doesn't doesn't mean doesn't mean it will behave like a clay. It will behave like a clay. Behave like a behave like a clay mineral. mineral exhibiting 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 plasticity and swelling, exhibiting plasticity plasticity and swelling, plasticity and swelling, plasticity and swelling, unless it has correct chemical structure, unless it has it has correct it has correct structure, correct structure and surface charge, and surface charge, surface charge, surface charge. So this question highlights the difference between size and mineralogy. Just because a particle is small enough to be classified as a clay sized, like rock dust, doesn't mean it will behave like a clay mineral, exhibiting plasticity and swelling, unless it has correct structure and surface charge. It has correct structure and it has correct chemical structure, correct chemical structure, correct chemical structure and surface charge. So this is all for today. The file is going to be very big. That is why I am facing the problem in writing. Okay. So this is all for today. Thank you, everyone.